On December 22nd, 2032, a 90-meter asteroid will enter Earth's atmosphere at nearly 40,000 miles per hour. The impact energy, equivalent to 15 megatons of TNT, that is more than 1,000 times the power of the atomic bomb dropped on Hiroshima. And according to the latest data, we cannot stop it. This is not a movie. This is not a drill. This is the story of 2024 YR4, and why your children may witness something humanity has never survived before. Late December 2024. At the El Sos Observatory in Chile, an automated telescope detected a faint speck of light moving against the stars. This object was designated 2024 YR4. It was roughly 28 million miles from Earth. The asteroid was flagged by automated warning systems and rose to the top of both NASA's Sentry Risk List and the European Space Agency's Asteroid Risk List, a catalog of objects with a non-zero chance of hitting our planet. Astronomers estimated its size at between 40 and 90 meters wide, roughly the size of a large building. As the news spread, the International Asteroid Warning Network issued a rare public memo. This happens only when a space rock has a greater than 1% chance of Earth impact. And 2024 YR4 did. In fact, the odds kept climbing. On February 19, 2025, NASA's Center for Near-Earth Object Studies calculated the impact probability at 3.1%, or roughly 1 in 32 odds, the highest ever given to an asteroid of this size in modern forecasting. To put that in perspective, it's about the same as correctly guessing the outcome of 5 consecutive coin tosses. When faced with such a threat, humanity has one tested method of defense: kinetic impact. In 2022, NASA's DART mission proved we could hit an asteroid and change its orbit. The spacecraft struck the asteroid Dimorphos, shortening its orbit by a full 32 minutes. For 2024 YR4, a similar mission was planned. But there was a problem. The asteroid's orbit is taking it out towards Jupiter. Its next close approach is not until 2028. That left barely enough time to design, build, and launch a spacecraft. A mission was fast-tracked. Resources were pooled. Engineers worked around the clock. The spacecraft launched in late 2027, the fastest kinetic interceptor ever built. On October 1st, 2030, it reached 2024 YR4. It hit exactly as planned. The impact created a massive plume of debris. Thousands of tons of rock launched into space, adding to the push. But when the dust settled and astronomers recalculated the asteroid's new path, the trajectory had barely changed. The problem was the asteroid's composition. 2024 YR4 is not a solid monolith. It's a rubble pile, a loose collection of rock fragments held together by gravity. The kinetic impact, instead of delivering a clean push, fractured the surface. Most of the energy was absorbed by the rubble. The recoil from the debris was far less than expected. A 2025 report by the European Space Agency warned that such rubble pile asteroids could absorb kinetic impacts without significantly changing course. And that is exactly what happened. So, on December 22nd, 2032, the asteroid entered Earth's atmosphere at nearly 40,000 miles per hour. It did not hit the ground as a single mass. At an altitude of roughly 10 kilometers, Intense atmospheric pressure shattered it into thousands of fragments. The resulting airburst released 15 megatons of energy, more than 1,000 times the Hiroshima bomb. The blast wave radiated outward at supersonic speed. Within a 50-kilometer radius, buildings were leveled, trees were flattened. The ground shook as if struck by a major earthquake. Anyone caught in the open was instantly killed by the overpressure. But the devastation did not stop there. The impact generated a fireball so intense that it ignited everything within 20 kilometers of ground zero. A massive dust cloud rose into the upper atmosphere. Within days, that dust had spread across the hemisphere, blocking sunlight. Temperatures dropped, crops failed, food prices skyrocketed. The impact winter lasted 2 years. Famine claimed 10 times more lives than the initial blast. The asteroid did not end civilization, but for the region struck and for the global economy, it was a catastrophe on a scale not seen in centuries. So, could anything have been done differently? What about a nuclear option? A nuclear warhead could have vaporized the asteroid, but doing so would have created thousands of radioactive fragments, many still on a collision course with Earth, and now impossible to track. Or a gravity tractor, a spacecraft that hovers near the asteroid, using its own gravitational field to slowly pull it off course. The technology is promising, but it requires years of lead time. We didn't have that. The brutal truth is that planetary defense is not a magic shield. It is a race against time. And for 2024 YR4, we lost. But here is what makes this story truly terrifying. The asteroid that struck Earth in this scenario, 2024 YR4, is small. A regional threat, not a global one. But there are larger objects out there, objects that remain undiscovered. According to NASA's NEO Surveyor mission, nearly 40% of near-Earth asteroids larger than 140 meters, objects capable of devastating entire countries, remain undiscovered. But 2024 YR4 is not the worst threat the universe holds. There is something far more powerful, something that could erase us instantly without warning. A gamma ray burst. A nearby GRB could strip away our atmosphere, boil the oceans, end all life on Earth in a matter of seconds. And unlike an asteroid, we would never see it coming. Next time on Cosmarium, subscribe now, before the next deadline finds you.